Imagine standing on a stable floor, yet feeling the ground is about to give way. Your heart races, palms sweat, even when you know you are safe. This is the daily reality of anxiety, and science reveals it is a full-body phenomenon. To understand anxiety, we must travel back 200,000 years. The human brain evolved on the savanna, where the primary threat was a predator lurking in the grass. Central to survival is the amygdala, a small almond-shaped cluster deep within the temporal lobes. It acts as the brain's threat detection center, scanning every sensory input for danger. Research shows the amygdala can process a threat signal in just 12 milliseconds, far faster than conscious thought can register. For someone with an anxiety disorder, this alarm system is not broken. It is calibrated too sensitively. The amygdala fires not just for physical threats, but for an email, a tone of voice, or an upcoming social event. This ancient wiring, once essential for survival, now triggers panic in safe environments. If the amygdala is the gas pedal of anxiety, the prefrontal cortex is the brake. The PFC, particularly the ventromedial prefrontal cortex, is responsible for rational appraisal and emotional regulation. It helps us say, that sound is just a branch, not a predator. A landmark study used fMRI to compare brains of individuals with generalized anxiety disorder to healthy controls. Those with anxiety showed hyperactivation in the amygdala and hypoactivation in the prefrontal cortex. The brain's alarm was blaring, but the regulatory brake failed to engage. This is not a sign of weakness. It is a measurable difference in brain circuitry, like a car with a stuck accelerator and a faulty brake line. Understanding this imbalance shifts the narrative from personal failure to biological reality. Perhaps the most revolutionary finding is that a significant portion of anxiety signaling originates in the gut. The gut-brain axis is a bidirectional communication network linking the enteric nervous system with the central nervous system. The gut houses trillions of bacteria, the microbiome, which produce neurotransmitters like serotonin, dopamine, and GABA. Groundbreaking research showed that transplanting fecal microbiota from anxious mice into germ-free mice caused the recipients to develop anxious behaviors. In humans, individuals with irritable bowel syndrome have higher rates of anxiety, and probiotic interventions can reduce both gut symptoms and anxiety scores. The feeling of butterflies in your stomach is not a metaphor. It is a literal signal from your gut microbiome to your brain. Parallel to gut-brain research, compelling evidence implicates systemic inflammation as a driver of anxiety. When the immune system is chronically activated by stress, poor diet, or infection, it releases pro-inflammatory cytokines like interleukin-6 and tumor necrosis factor alpha. These molecules can cross the blood-brain barrier and directly influence brain function, particularly in the amygdala and prefrontal cortex. A meta-analysis found that individuals with major depressive disorder had significantly elevated inflammatory markers, and subsequent research confirmed the same for anxiety disorders. A study following over 2,000 older adults found that those with high levels of C-reactive protein were more likely to develop anxiety over 2 years. This suggests that anxiety can be driven by a body that is literally on fire with inflammation. One of the most persistent stigmas is the idea that anxiety is a choice, but genetics play a powerful role. Twin studies show that anxiety disorders have a heritability of 30 to 50%. Specific genes, such as those affecting the serotonin transporter and the COMT enzyme, influence how the brain processes stress. These genetic variations affect the structure and function of the amygdala and prefrontal cortex, making some individuals more vulnerable to anxiety. This is not a character flaw, it is a biological predisposition. Understanding the genetic component helps dismantle blame and opens doors for personalized treatments. The science makes clear, anxiety is not a failure of will, but a complex interplay of biology and environment. If anxiety is rooted in biology, can it be changed? Yes, through neuroplasticity, the brain's ability to reorganize itself. Cognitive behavioral therapy, for example, strengthens the prefrontal cortex's ability to regulate the amygdala. Repeated practice of new thought patterns builds new neural pathways, effectively rewiring the alarm system. Exercise, mindfulness, and even dietary changes can reduce inflammation and support a healthier gut microbiome. Medications like SRI increase serotonin availability, helping to calm the overactive threat response. The key is that treatment targets the biological underpinnings, not just the thoughts. Anxiety is not a life sentence. It is a condition that can be managed with science-backed interventions that address the whole body. Anxiety is not a weakness. It is a biological system gone awry. If you found this valuable, consider exploring how these insights can transform your understanding of mental health.